Hello, welcome. Today let's try to solve another Leetcode problem 743, network delay time. So we are given a graph and it is a weighted directed graph. So for example, 2 directed to 1 and there's a weight of 1. We're just going to return the minimum time it takes for all the n nodes to receive the signal. So this means, for example, if k equals to 2 for the first example, so this k for this node, it can go to 1, it can go to itself, it will be 0. If it go to 1, it is 1. If it go to 3, it is 1. If it go to 4, it is 2. So the minimum the minimum time is 2. Actually, it is the maximum of all those numbers, because if we were to go from node 2 to node 4, at least we'll take 2 time. So this is why the minimum. For this problem, I'm going to use a simplified disastrous sorted path algorithm to solve the problem. But I'm also going to use a priority queue just to make it speed faster. I'm going to use E log E time complexity for this algorithm. So E is the number of nodes. E is the number of edges. So inside, so for this time times dot less is 6,000. So I'm sure I can pass for this disastrous algorithm. Yeah. Now I'm going to prepare for a priority queue and a distance dictionary. So for here, I'm not going to use a distance array. I'm going to use a distance dictionary because I'm going to check if a node is inside my dictionary or not. And I'm also going to prepare. Let me think. I'm gonna a graph. Just to prepare all the edges. So this is a adjacency list for this graph. So for the PQ, I'm going to compare the shortest time. So inside, I will give the first node with time. So it is 0 with k. So the first node is k, and this time for this node is 0. And I'm gonna use a default dict. Default dict int for this dictionary, and for the graph, I'm gonna use a default dict list. So this is an adjacency list, and this is just a dictionary inside it. It is a k-value pairs, and it will store just the node and the time. This is for node and time, and this is the priority queue. It is the time and node. Now I'm going to prepare for the adjacency list. So for UV, let me make it W in times. So G.U should append inside, it will be edge and time W. Now I'm going to check for the priority queue. So it will pop out the first one. It will be the time and node will be PQ. I will use hip pop with this priority queue. Now I'm going to check if this node is inside the dictionary or not. So if not in dictionary, I'm going to update the dictionary and prepare the shortest distance for this node. So the D node should equal to time. Because this is inside the priority queue, so I'm sure the shortest time for this node must be the time. For example, for the first node, it is 0. This dk, if k equals to 2, d2 should equal to 0 for the first one. So the d2 should equal to 0. So this is according to the property of the priority queue. I'm sure this node will always have the short time, and then my graph will traverse from this node. So for the neighbor and weight, So I will make a time, t as time, for neighbor and time in g naught. So I will check all those neighbors, but I don't need to check which distance is shorter because I used the priority queue. So I just need to put it inside the priority queue. Although it takes a little bit time, but yeah, still it is a simplified version of a Dijkstra's algorithm, and it's easy to handle with the with the shortest answers. So I just need to put it inside. So I gonna use a heap push with the priority queue, and inside it will be the time plus this t and with this neighbor. Yeah, because this priority queue is for this time, so the first one will always be time. So this is what I designed for the time and this node. Yeah, so for the next loop, so the next shortest node will be put inside this PQ. So first one, it is a 2. So for the next time, it will be 1, and I will get a value of 1. And the next time, I will get because there's no neighbors, so it will not put inside the queue. But I can next time put 3 inside my queue and get a distance of 1. Yeah, and then I'm gonna check its neighbors. Yeah, so for this neighbor, it is 1 plus 1, it is a 2. So I put it inside the queue and pop out and get the distance. Yeah. So this is the entire code. I just needed to return the final result. So I needed to return the maximum of d dot values because d dot values is a distance dictionary, and inside it is the maximum of the distance. So I'm going to use d max. But I have to check if this node can traverse through all the nodes. It means it can go through all the nodes. If it cannot, I'm going to return a -1. So how can I check? I just need to check the length of the dictionary. Yeah, if this length is equal to n, so I'm gonna return the max d dot values. Otherwise, I'm gonna return a -1. Yeah. Now let me just run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's also pretty fast, and it passed all the testing cases, and the time complexity is in this PQ area. And the maximum node inside this PQ can be the number of edges. Yeah, because this is the number of edges with each neighbor. And for each pop or push, it will take n log n time. So there are n edges. So the time complexity will be, yeah, let's name it E, will be E log E. So E is the number of edges. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problem like this. See you next time.